Hello, my name is Jimenez Kaufmann. I am a PhD student in the University of Copenhagen at the Novo Nordisk Foundation Center for Protein Research. First, I'd like to say thank you for having an interest in this poster and thank you for watching this video. Today, I will be presenting to you one of my PhD projects that has as a title, Identifying Potentially Underdiagnosed Patients of Systemic Autoinflammatory Diseases in a Population-Wide Registry. So first, what are systemic autoinflammatory diseases? These are a group of rare diseases that are the result of the dysregulation of the innate immune system. They are characterized by symptoms such as periodic fevers, systemic and organ-specific inflammation, rashes, chest pain, among others. But the important thing here is that these symptoms are shared among all of these diseases. So no one disease has a particular symptom. And this is one of the reasons of why these diseases are so hard to diagnose. In the end, only around 40 to 60% of patients will get a specific diagnosis. So the aim of this project is to identify underdiagnosed patients in the Danish National Patient Registry. Very broadly, the question of this project is, can we identify patients that have been underdiagnosed for MSA? To do this, I'm using the Danish Health Registry. So this registry has followed the health of the Danish population from 1977. It has tracked around 7.2 million patients, and it has recorded around 200 million diagnoses. So first, to be able to identify underdiagnosed patients, first we need to know how diagnosed patients actually look like. And to do this, we are using a strategy called disease trajectories. So very simply put, disease trajectory is a time-ordered diagnosis events that happen more often in a population. So for instance, you can get first in your life diagnosis A, and then diagnosis B, and then later in life, diagnosis C and D, and so on and so forth. But the point is that some of these trajectories or time order events are more common for certain diseases than others. So some of these trajectories are very good descriptors of certain populations. And we can actually stratify patients with this strategy. So to do this, I took a list of states that you can consult by scanning the QR code in the bottom of the poster. I stratified these states in early onset and late onset. Early onset would be around, the median age of onset would be around 10 years, and for the late onset would be around 53 years old. So now that I have the trajectories for late onset states and for early onset states, I can map individuals that have not been diagnosed with a state to these trajectories. So that's what I did. So I took all the patients that have not been diagnosed with a state, and then I asked, as for any particular patient, I asked, has this patient had this sequence of diagnosis events in their clinical history? Yes or no? So you can be a trajectory follower in two ways. You can be a strict trajectory follower if your clinical history has the exact events in the exact same order, or you can be a non-strict trajectory follower if you only have the diagnosis in any particular order. So in the end, for early onset state trajectories, I could identify 904 strict trajectory followers and 3,065 non-strict trajectory followers. On the other hand, for late onset state trajectories, I could identify 4,236 strict followers and 9,447 non-strict followers. So now we have this identified group of potentially underdiagnosed patients, but we would like to validate this identification strategy. And to do that, we fortunately have access to laboratory value data for a subset of them. So in the future, we will obtain the laboratory value for these patients, and then I will compare our potential SAPE patients to the real SAPE patients to see if they really look like each other when it comes to their laboratory data. And yes, these will be all for my part. And again, thank you very much for watching this. If you have any questions, please feel free to write me an email, and I will do my best to answer. Goodbye.